What is the motivation behind developing the Phi-3 mini model?
The motivation behind developing the Phi-3 mini model is to create a highly capable language model that can achieve performance levels comparable to much larger models, such as Mixtral 8x7b and GPT-3. 5. While maintaining a small size that allows for local inference on modern phones. The Phi-3 mini model with 3.8b parameters was trained on larger and more advanced datasets compared to its predecessor, Phi-2, and was designed to interact with data in novel ways by combining LLM-based filtering of web data and LLM-created synthetic data. The goal was to demonstrate that by focusing on the quality of training data and deviating from standard scaling laws, smaller models can reach the level of larger models in terms of performance. Additionally, the Phi-3 mini model was quantized to 4 bits to reduce memory usage, enabling it to run efficiently on devices like the iPhone 14 with a 16 Bionic chip. Overall, the motivation behind developing the Phi-3 mini model was to push the boundaries of what small language models can achieve by optimizing data quality and model size for enhanced performance and efficiency.
How does the proposed Phi-3 mini model work? Please provide a step-by-step explanation.
The proposed Phi-3 mini model is a transformer decoder architecture with a default context length of 4K. It can also be extended to a long context version with a context length of 128K, called Phi-3 Mini 128K. The model is built upon a similar block structure as Llama 2 and uses the same tokenizer with a vocabulary size of 32,064, allowing for easy adaptation of packages developed for Llama 2 models. It has 3,072 hidden dimensions, 32 heads, and 32 layers. The model was trained using bfloat16 for a total of 3T tokens. The Phi-3 mini model is chat fine-tuned and can be quantized to 4 bits, occupying approximately 1.8 gigabytes of memory when deployed on a modern phone like the iPhone 14 with a 16 Bionic chip. The model achieves more than 12 tokens per second when running natively, on device, and fully offline. The training methodology of the Phi-3 mini model follows a sequence of works initiated in Textbooks Are All You Need, which focuses on utilizing high-quality training data to improve the performance of small language models. The training data consists of heavily filtered web data from various open internet sources, as well as synthetic LLM-generated data. The training is performed in 2 phases. Phase 1 involves web sources to teach the model general knowledge and language understanding, while Phase 2 merges filtered web data with synthetic data to teach the model logical reasoning and niche skills. The model is calibrated to be in the data optimal regime for small models, focusing on the quality of data for a given scale rather than compute or overtraining regimes. Post-training of the Phi-3 mini model includes supervised instruction fine-tuning and preference tuning with DPO to improve chat capabilities, robustness, and safety. The model undergoes evaluations across dozens of RAI-harm categories to ensure alignment with Microsoft's responsible AI principles. Red teaming and automated testing are conducted to identify areas of improvement, resulting in a significant decrease in harmful response rates. The model is evaluated on standard open-source benchmarks measuring reasoning ability and compared to other models like GPT-3, 5 and Mixtral 8x7b. Additionally, safety benchmarks are conducted to evaluate the model's responses in terms of groundedness and harmfulness. Despite its capabilities, the Phi-3 mini model has limitations related to its size, such as limited factual knowledge storage and language restrictions to English.
What are the technical specifications of the Phi-3 mini model, including architecture details and training data?
The Phi-3 mini model is a transformer decoder architecture with a default context length of 4K. It also has a long context version called Phi-3 Mini 128K, which extends the context length to 128K. The model is built upon a similar block structure as Llama 2 and uses the same tokenizer with a vocabulary size of 32,064. It has 3,072 hidden dimensions, 32 heads, and 32 layers. The model was trained using bfloat16 for a total of 3T tokens. The training data consists of heavily filtered web data from various open internet sources aimed at teaching the model general knowledge and language understanding in PHASE1. In Phase 2, more heavily filtered web data is merged with synthetic data to teach the model logical reasoning and various niche skills. The model is already chat fine-tuned and can be quantized to 4 bits, occupying approximately 1.8 gigabytes of memory, allowing it to be run locally on a modern phone.
What theoretical or practical benefits does the Phi-3 mini model offer compared to larger models like Mixtral 8x7b and GPT 3.5?
The Phi-3 mini model offers theoretical and practical benefits compared to larger models like Mixtral 8x7b and GPT 3.5 in several key aspects. Firstly, despite its smaller size of 3.8b parameters, Phi-3 mini achieves performance on par with larger models due to its innovative training methodology that focuses on data quality rather than sheer scale. This approach allows Phi-3 mini to match the performance of models 25 times larger trained on regular data. Additionally, Phi-3 mini can be easily inferenced locally on a modern phone, providing a more efficient and accessible solution compared to larger models that may require more computational resources. Furthermore, Phi-3 mini can be quantized to 4 bits, occupying approximately 1.8 gigabytes of memory, making it more lightweight and suitable for deployment on devices with limited resources. Lastly, Phi-3 mini undergoes rigorous post-training processes aligned with responsible AI principles, ensuring safety, robustness, and alignment with ethical standards, which is crucial for real-world applications.
How was the Phi-3 mini model validated and tested for performance?
The Phi-3 mini model was validated and tested for performance by quantizing it to 4 bits, allowing it to occupy approximately 1.8 gigabytes of memory. The quantized model was deployed on an iPhone 14 with an A16 Bionic chip, running natively on device and fully offline, achieving more than 12 tokens per second. Additionally, the model underwent post-training with both supervised instruction fine-tuning and preference tuning with DPO, which improved its chat capabilities, robustness, and safety. Furthermore, the model was evaluated on standard open-source benchmarks measuring its reasoning ability, including common-sense reasoning and logical reasoning, using few-shot prompts at temperature 0. The results were compared to other models like PHI-2, Mistral 7b VO1, Mixtral 8x7b, Gemma 7b, Llama 3 Instruct-8b, and GPT 3.5, ensuring that the numbers were produced with the exact same pipeline for comparability. The model's safety was also assessed through in-house RAI benchmarks, comparing Phi-3 mini 4K and Phi-3 mini 128K to other models like PHI-2, Mistral 7b VO1, and Gemma 7b, evaluating responses in terms of groundedness, harmfulness severity, and defect rates.
What limitations or weaknesses are mentioned for the Phi-3 mini model in the paper?
The limitations or weaknesses mentioned for the Phi-3 mini model in the paper include its fundamental size limitation in storing factual knowledge, leading to lower performance on tasks like trivia QA. Additionally, the model's capacity is restricted to English language only, highlighting the need to explore multilingual capabilities for small language models. Despite diligent responsible AI efforts, challenges such as factual inaccuracies, biases, inappropriate content generation, and safety issues persist. The paper acknowledges the ongoing work to address these challenges through curated training data, post-training improvements, and insights from red teaming. The weaknesses of the Phi-3 mini model underscore the importance of continuous development and refinement to enhance its performance and mitigate potential risks.